Hello everyone, welcome to our video presentation. Today, we are reviewing a complex study from 2026 titled Production of Auric Mitigation Matrix using Cox Regression to predict osteoarthritis development. I'm Aditya Erlangga, and I'm joined by my partner Cikal Hanif. We are students from the Statistics Department ITS. In this video, we will break down how statistical modeling, specifically survival analysis, is being used to cut joint disease before it's too late. Let's get started. Here is the roadmap of our discussion today. I will be covering the first two sections, the research motivation and the statistical methodology. Then we will transition to the main findings, critical analysis, and future directions, which will be presented by Cikal. We've designed this analysis to provide a clear view of high-level statistics with clinical reality. First, let's look at the problem. Osteoarthritis, or we can call it OR, is a progressive painful disease. The issue is that standard tools like MRI or X-rays are reactive. They usually only see damage once it's structural and irreversible. Research gap here is critical. We lack the standardized biochemical threshold to catch the disease in its early tracks. The authors motivate this study to create a risk mitigation matrix that gives clinical actionable numbers to work with before the patient requires surgery. How did they do it? The study analyzed data from 86 subjects, focused on three key inflammatory biomarkers, IL-6, TNF-alpha, and MPO. Statistically, they innovated by using the Cox pH model. Even though this was cross-sectional data, they treated disease status as a simulated survival endpoint. This allowed them to estimate risk without restrictive baseline assumptions. To ensure accuracy, they validate the model using DFA or discriminant function actions. That concludes the background and the methodology. And now, Cikal will walk us through the result and our critical analysis of the paper.
Let us discuss the main findings of the paper. The study successfully established specific biomarker threshold for early Oeric detections. LS6 greater than or equal to 6.95 pg per ml, TNF-alpha greater than or equal to 40.51 pg per ml, and MPO greater than or equal to 5.45 pg per ml. The statistical models was highly significant with a p-value less than 0.001. Among our predictors, MPO acting as the strongest predictor, and the DFA classification model achieved an accuracy of approximately 71.8%, which indicates reasonably strong predictive performance. Biologically, IL-6 and TNF-alpha were associated with inflammation processes in the joints, while MPO tracks oxidative tissue damage from across disease stages. The study has several strengths. First, the study innovatively adapts survival analysis method for cross-sectional data, allowing the researchers to create practical fertile clinical risk matrix. Second, the researchers perform strong data preprocessing techniques, including blockchain transformations, statistical normalization, and removal of extreme outliers, ensuring high statistical reliability prior to modeling. However, there are also some limitations. The sample size was relatively small, the study lacked longitudinal tracking, and important confounding lifestyle variables such as BMI and diet were not included in the model. The paper also suggests that integrating advanced machine learning models could define diagnostic and capture nonlinear biomarker interactions much better than deterministic DFA. For future improvements, the researcher proposed several recommendations. First, Future studies should involve larger and multi-center datasets that include lifestyle coverage and other markers like C-reactive protein. Second, longitudinal studies are needed to track real-time symptom changes, supported by tissue culture models. Finally, the biomarker-based model could eventually be integrated with MRI or X-ray for more precise disease staging and may also be used in clinical trials to evaluate new osteoarthritis treatments. That's all from us. Thank you for the attention.